Okay, in this video we're going to be covering simulation data and how that in turn is going to help you solve the Open Rocket Challenge. Before we go ahead, I want you to do two things for me. First thing I want you to do is I want you to save a new copy of your completed Estes Alpha rocket in the event that you need to go back to the original design. You will have that original file. So here's how we're going to save this, and this is also how I want it to be saved so that when you submit it, it has your name and period number. I'm going to go to File, Save As, and I'm just going to save this to my desktop, which is fine. I'm going to rename the file as my last name. I want you then to put in your last name and your period number. I'm just going to use the number 1. And I'll just type in Open Rocket, which is fine. Most importantly, your last name, your period number. I'm going to hit Save. The second piece, this is also going to be very helpful, is to change the units to Imperial. They're currently set to metric, as you'll see metric here, and metric over here. So we're going to go to Edit. Under Edit, go all the way down to Preferences, and you have a tab called Units. Let's go ahead and select what's called Default Imperial. Now keep in mind when you set this to Imperial, you'll still notice everything is in metric. It says the effects will take place the next time you open really any window. So watch this. I'm going to hit Close, and we can actually simplify this. If I click on any part, don't double click, single click on any part, all of these units will change to Imperial, which is inches, feet, miles example. So let me just click on launch lug or body tube. You can already see that the changes took place at the bottom of my screen. Okay? So currently we have a rocket that has a cal of 2.04. Keep in mind we had a discussion about this in class. Usually want this number to be between 1 and 2, which means the distance between your CP and CG are a distance of 1 body tube diameter and or 2 body tube diameter. So once again, the number we're shooting for is between 1 and 2. It's okay if you're just over 2 and just under 1. And this discussion will continue as we go through these tutorials. So for right now we do have a slightly overstable rocket, but let's focus on the simulation portion of this. In the video that you used to create this rocket, I'm going to come up here to Motors and Configuration. You already selected a B64 and a C65. As I discussed with the problem, you have a choice of using any B engine with any delay, any C engine with any delay. So I'm just going to leave these two engines here for now, but there are ways to change the motors, which was discussed in the first video, which allowed you to build this rocket. So we're going to move on now to flight simulations. So here's what we need to look at. Once again, we've changed the units to Imperial. First line is our B64 engine, which we obviously know is less powerful than a C6. That's a B6-4, which means it has a 4-second delay. The two big variables we're going to look at are apogee. Currently this rocket is hitting 399 feet. And if we take a look all the way to the right is the flight time. So these are the two columns that we need to focus on as we're trying to solve a two-part problem. Remember, you are given an apogee that you've been asked to reach with, for example, a window and a specific flight time. Okay, now all these other variables are important, but for now let's focus on apogee. Focus on flight time, and once again we have a slightly overstable rocket, so this rocket could become more, shall we say, less stable, making it really something between 1 and 2 and or we could actually go just under 1. Now keep in mind, by making it less stable to go higher, but at the same time it's maybe a little bit less stable. If we make it overstable, it will go lower, but once again, it'll have more drag on the rocket. So let's jump over here and click on the B64. And let's go ahead and hit Run Simulations. And I'm going to go ahead and select Plot Export. So once again, I selected the motor, I hit Run Simulations, and I hit Plot Export. You always need to hit the Run Simulations button with the motor you're going to use if you've made changes to the rocket. Okay, you cannot just go ahead and hit Plot Export. So make sure you do that every single time you make any change to your rocket. On this screen, I'm just going to hit Plot. And here we go. So let's take a look at 2 pieces of data. Once again, the screen we were just looking at really tells us everything we need to know, but you also just need to pay close attention to what this data is telling us. You can see this red line. Let's just focus on the red line. The red line, as we can see here, is the altitude. From ignition, this rocket is hitting an altitude of 400 feet, and it takes it just about 5 seconds to reach that apogee. Okay, about 5 seconds to hit an apogee of 400 feet. It's then taking the remaining time, as you can see here by the red line, to fall with your recovery system. In this case, we're using a parachute. And once again, you'll have a choice of either a parachute or a streamer. So this red line here is telling us basically the rocket's course during this time of 33 seconds, reaching an apogee of 400 feet. It's actually 399. One last thing I want you to pay close attention to. You typically want the apogee and the recovery deployment to either happen at exactly the same time, and or it is ideal, because that can be complicated, for apogee to first take place and then soon after recovery of your recovery device deploying. Okay, if you look at these 2 lines here, you'll actually see, it's kind of hard to see, this blue line on the left is our recovery deploying, but very, very soon after it's then hitting apogee. If your recovery is coming out too early, if your recovery came out here, for example, you're going to prevent your rocket from hitting its highest point. Okay, so it's very important, once again, that you understand that this red line really is of much importance here, just to kind of see this flight pattern. But once again, pay close attention to when the deployment takes place and when apogee takes place. And once again, at the same exact time, which means this is actually pretty good if you look at the interval between deployment and apogee, and or apogee happens first and then soon after you have your recovery device. Okay, once again, allowing the rocket to reach its maximum apogee. So let's go ahead and hit close. Let me go ahead and hit close again. If you want to run the C6-5, remember you have to click first on the rocket engine, hit Run Simulation, especially if you made any changes to the rocket itself. Okay, you can usually see, you get this nice visual, this little green circle here is telling us we've done something new. And now we're going to hit Plot Export. And before we do that, we can see this apogee is significant. It's basically double of what a B engine was delivering. This is a C6-5, 5-second delay, much more powerful engine, twice the apogee. But at the same time, you'll also notice the flight duration is going to take longer. Of course, it's going higher, which means it's going to take longer to get at apogee and longer to come down. So I'm going to go ahead and, once again, I hit Run Simulation. I'm going to hit Plot Export. On the screen, just hit Plot. Don't change anything. And once again, you can see it took about 7.5 seconds, which again, a much more powerful rocket engine. So it's actually moving much faster. 7.5 seconds to hit 800 feet. And once again, The blue line is the recovery ejecting, and the green line right next to it is the rocket hitting Apogee. Not bad if you look at the time frame between the recovery system coming out and hitting Apogee. But once again, we do not want too big of a gap, meaning we would not want the recovery coming out here, for example, and then the Apogee happening sometime after it. Okay, so just keep an eye on that. In a perfect world, either exactly at the same moment and or what you're seeing here, or Apogee first and then recovery sometime soon after. Well, now, once again, look at this time. This is a flight time of 65 seconds. Okay, once again, it's going twice as high, powerful engine, but it's going to take longer to come down. And remember, this can be controlled with either a streamer or a parachute. You can change the size and shape. This can be controlled with a different engine, but also, let's keep in mind, this can also be controlled, Apogee can be controlled by the shape and size of your body tube, meaning making it longer or shorter. Do not change the diameter of the body tube, longer or shorter. The size and shape of the fins, the number of fins, these are all different variables, okay? So we're gonna go ahead and stop this video right here. Once again, this video was covering the simulation data. Remember, keep your eyes on Apogee, keep your eyes on flight time, keep your eyes on your stability. Once again, a slightly overstable rocket, but once again, as we move through the next videos, we're going to be able to start changing the size and shape of these parts. This will start to adjust along with some of these other variables. You're also going to see the Apogee is here with the current engine that you have selected. Okay, let's move on to the next video.